Can the molecule be temporarily excited to a higher, unstable state before returning to a different vibrational energy level? If the molecule returns not to its original ground state but to a slightly higher vibrational excited state called nu, does the scattered photon have less energy than the incident photon? What do we call the specific kind of energy loss during scattering? Could it be the origin of what are known as Stokes lines in the Raman spectrum? Can Davis-Serinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? When Stokes scattering occurs, is the frequency of the scattered light lower than that of the incident light? And how does that relate to the energy lost to molecular vibration? On the other hand, what happens if the molecule is already in an excited vibrational state, nu, when it interacts with a photon? Can this photon still excite the molecule to an even higher unstable energy state? And what happens when the molecule relaxes back down? Not to the excited vibrational level but to the ground state nu. In that case, does the scattered photon gain energy relative to the incident photon? And is this process called anti-Stokes scattering? How does this affect the frequency of the scattered light? Does it become greater than the frequency of the incident light? Why do we categorize both Stokes and anti-Stokes lines together under the term Raman spectral lines? And what does this classification help us understand about light-molecule interactions? Since most molecules at room temperature tend to remain in their vibrational ground state, does this mean that Stokes scattering is more common than anti-Stokes scattering? Why is the intensity of the Stokes lines generally stronger than that of the anti-Stokes lines? Could it be due to the larger population of molecules in nu compared to nu? How does this difference in population distribution between energy levels influence the Raman spectrum that we observe experimentally, and what insights can it provide about the molecular structure and environment? Could Raman scattering be used to determine vibrational modes of molecules, and what practical applications does this kind of spectroscopic technique offer in chemistry, physics, or material science? What are anti-Stokes lines, and how do they differ from Stokes lines in the context of Raman scattering? Why are anti-Stokes lines generally weaker in intensity compared to Stokes lines, and what does this indicate about the population of molecules in different vibrational energy states? When we talk about the Raman shift, what exactly are we referring to, and how is the shift measured? Is the Raman shift defined as the frequency difference, symbolized as delta nu, between the Raman scattered light and the incident light? Why does this frequency difference matter in the context of molecular analysis, and how does it help us understand what's happening at the molecular level during scattering?